everyone. My name is Colin Murphy. I'm an engineer at Adobe. I'm also a member of the W3C WebAssembly group and the Wasi subgroup, and a maintainer of wasmCloud. I'm presenting these slides using Adobe Express, a product I worked on for a couple years. Please do not hold my ugly slides against the product. And they are ugly. I'm not being modest. So in this talk, I'm going to cover what kind of problems the component model can solve and what would motivate someone like me to use it. A practical walkthrough of how to create components for real SDKs. And then, if I may be so bold, how the component model can lead us to a transformation of the web. Okay, so my team at Adobe is the Content Authenticity Initiative team. And what is that? It promotes an industry standard for provenance metadata, called content credentials, to help curb disinformation and increase trust and transparency online. Membership includes camera manufacturers, editing software, media companies, social media companies. And Adobe is a member of it. There are also two other groups that are closely related: C2PA, which is the tooling and the use of content credentials, and then the Creator Attribution and Working Group. Creator Attribution Working Group, and that's around signing your work. So you've made work and you sign it, and you know that it is yours if somebody else uses it, or other reasons. Okay, so why would Adobe, specifically the Content Authenticity team, use components? Okay, so today maintaining SDKs and services is very labor intensive. We have lots of feature requests from internal teams, external partners, across a wide range of use cases. In some embedded use cases, web use cases. So the big idea, and if you saw Luke's talk from yesterday, shouldn't be surprising, is that one component could run as a web service. We could generate SDKs from our main Rust SDK, and even run on embedded devices. I'm not going to talk about creating full SDKs from a component. I haven't gotten that far yet. And that would require packaging a runtime within the SDK for things like C, things other than JavaScript. And maybe that'll be a future talk. Instead, I plan on focusing on how to create and use a component. Okay, so I've identified 4 steps. Number 1, get everything compiling to WASI P2. That used to be the whole talk. 2, define interfaces. I think we've seen a few examples of that today. And then implement the main API component, what that looks like. And then implement dependent components in different languages and compile and whack them all together. So lots of progress has been made on just dependencies. 2 years ago, I gave a talk around this, and it took, I think I had to fork 8 different crates. That took many nights and weekends to get that working. But now I have C2PA RS, our Rust crate. Our C2PA crate officially supports WasmCloud Wasi P2 without any forks. And even the CLI tool, the C2PA tool, just works with wasmtime. You can do wasmtime, C2PA tool, give it the right directory permissions, and it'll run. And now I am biased, but I find it easier to build for Wasi P2 than wasm32 unknown with wasm bindgen. And having the ability to use standard lib APIs, file systems specifically for C2PA, is a big plus. And it actually is less configuration and additional code than wasm bindgen in our SDK. Also, WSTD, at WSTD, super valuable for tests, NHTTP. I mean, we've seen it in multiple talks today. It's invaluable since we don't have Tokyo or request support yet. OK, so step 2, defining interfaces. This was actually very straightforward for me because we already had so many forward function interfaces, so many language bindings for C2PA RS. I just basically took that very explicit public API and I just kind of converted it into WIT. I think the real challenges for people like me when you're really, I'd heard about importing and exporting and using, but it's not obvious. It's not obvious what a world imports and exports and how that works. So that definitely takes some getting used to. I'm going to have to do it eventually. So I'm going to try to show if. Oh man. OK, hold on. Shortcuts? No. Oh, there we go. OK, so this is the WIT. This is the main part of the WIT file. So as you can see, I've got a couple resources and I've got a function. This is the main interface. There's also a types interface, which is very large, but really not used. But pretty basic, really straightforward, pretty easy to see. Okay. Back. All right. Use streams is another piece of advice I'd have. You do not want to duplicate large data buffers on both sides of a component interface. And with 0.3, streams are going to be even easier. Let's see. One challenge, so kind of why we have to use big files, why we have big things, is one challenge particular to C2PA is that applying credentials to media containers, right? So pictures and video, think of that. When I say containers, that's what I'm talking about. Requires seekable streams because when you're validating an image, let's just say, you have to jump around within the file. So you can't just stream it and consume the stream. You have to jump back and forth. So it has to be a file, or it has to be a buffer. And if it's a video, there's no way you're going to get that into memory, especially in these kind of Wasm, very small type use cases. So you have to use file descriptors. I did not know about file descriptors when I first started this project. I wish I had, but really very useful. And you can get seekable streams really easily from them. So to do this, I created 3 interfaces and 4 worlds. That's the talk. The interfaces are C2PA, which I just showed you, Signer, which I'll get to in a little bit when I talk about callbacks and first-class functions, and the types, which I kind of already mentioned. And then these interfaces are utilized by 4 worlds. The main world, CAI, which is going to be the main component is going to implement. The signer, which wraps the signer function and allows it to be used as an argument in the CAI world. And then C2PA tool, just a CLI tool. Really just something that uses the CAI world, and then also the C2PA web server, which exports the incoming handler. So you can make a web service. I did it in Node in this example. The rest I implemented in Rust because that's easier for me. So then implementing. So I wanted to create this main component. And it's pretty familiar to anyone who's done FFI bindings. So Unify, or I've been using a lot of Neon for Node recently. WIT bindgen, very mature. The best bindgen, the best of the bindgens. Additional derives, I'll show in a little bit, is basically WIT bindgen would be unusable for this kind of use case, for an actual real SDK with lots and lots of types without additional derives. And then wstood, I don't know if I'm pronouncing that right, but definitely needed for if you want to do any sort of tests. See if I can once again tempt fate and OK. Right. So it was just implemented in librs. Nothing. This is a public repo. The SDK is also public. This is all open source. Just going to go back. Just going to describe what you're seeing here. OK, so this is the big idea, right? If I go back to that world, I had an interface called C2PA. I defined a function, and I defined 2 resources. And I'm going to implement the guest for that. So I just defined a struct. It could have any name, manifest in this case. I implement guest for the manifest. I have to define the functions and just and define some types. And then I get C2PA builder from my SDK, the C2PA RS SDK, and I just wrap that in a ref cell. And then from there, I'm just passing on the arguments from the WIT definition into the SDK. And for almost everything, super straightforward. WIT gets mapped into a certain type of Rust type. You can either use that Rust type directly, or you can convert it into whatever you need it to be, the closest type from WIT. And then you call the SDK methods. Really, really basic. For the most part, until you get to first-class functions. There are some gotchas around WIT-bindgen. If you notice here, I've got statements here that say generate, and I have some that say wasi-io, : So generate is typically what you do with WIT-bindgen. It just sees the WIT, and it knows what to do to make Rust structs and types and interfaces, things like that. But unfortunately, I needed input stream, so I needed wasi-io input stream to have read and seek. So that's not done by WIT-bindgen, but that is done in the wasi-crate. So you can specify, no, I want to use the crate implementation. I don't want to use your WIT-bindgen, which is great. Makes it possible for me to do this example, make this code. But the problem is that when you use the wasi-crate, whatever version you have locally, the interface version might not be 0.24. And you might have written 0.24 here. Doesn't mean it's going to actually be 0.24. So when you whack you'll be able to build just fine. But when you whack the components together, it's going to give you a type mismatch. And there is good news. There is Wasm tools. So Wasm tools, component WIT, you can use that to debug. Make sure you print out your WITs from the components and see which one doesn't have the version of the interface that you were expecting. Other than that, additional derives makes this possible. This would not be possible to make an SDK without additional derives. SERDI, deserialize, serialize would not be possible to implement on all of these structs I'm creating. So the only problem with that was it will crash. Well, WIT-bindgen will fail if it's trying to implement the derives on a resource. And if you wrap resources in a variant, right, and an enum, it doesn't know what it's doing. It doesn't know that they're resources, and it'll fail. So I just added to WIT-bindgen this little ignore thing. So I said, hey, I've got these 2 variants. They wrap. They have one option of the variant is a resource, so just ignore it. And then you can SERDI deserialize and deserialize all the types you generate. OK, so first-class functions. Ordinarily, in a Rust crate, in a public SDK, you don't want to have traits be part of that public SDK, unless you have a good reason. So because it adds complexity, it can slow things down. It makes language bindings, aka WIT, really difficult. In this case, though, the CAI team, we have a very good reason, and that's that a cryptographic signer is provided by the user, and they don't want to have to pass that into the SDK. this allows the user to sign their manifest or apply their cog credentials without passing their private key. So this is by design a callback function, and that's just part of the public API. Callbacks are supported. I mean, if you've done Wasm bindgen, if you've done an mscripting, you can use callbacks to functions. So this is from the JS SDK for Wasm bindgen. Yeah, here's a pointer to a function. That's perfectly fine. Problem is, this can't be expressed in WIT, and it can't be expressed in WIT for a reason, which I don't fully understand, but was explained to me yesterday. But around, you have loops. You don't know that both sides need to understand that a callback has been passed, right? And when you know you're going to JavaScript, JavaScript is aware of that there's a callback that needs to be there, but you can't just do that generally. You have to, at least not yet, but this will be implemented. Yeah, we're gonna. All right. So since I can't pass a callback as an argument in WIT, the signer function needs to be defined in an interface, implemented in a separate world, referenced in a separate world, implemented into a component, and then imported into the main CAI world. So that function, you can see it right there. That func data list U8 returns result list U8 error. So this is how because WIT doesn't support callbacks, this is how you can make it work. In the main C2PA SDK component, the import is wrapped in a struct, and the signer trait is then implemented. I mean, and this would have to be done regardless, right? Even if we did support callbacks, we're not going to support traits in WIT, right? We're not going to support Rust traits in WIT. So you would still have to do this. And then this implementation of the trait is instantiated in the main component, implementation of the main component. You can see here, let signer. There's some sort of a little bit of a configuration, and then we pass that. So that import gets wrapped it gets wrapped in a struct which implements a trait, and then we pass that func to the main SDK. So in summary, instead of taking a function as an argument, as a callback function, the signer is defined in a different interface, imported into a different world, which is compiled into a component, imported to the main component, wrapped in a struct that implements the desired trait, and finally passed the original method in the SDK. So that's a lot. And certainly, if you were doing this every time you had a callback in your SDK, it would be unsustainable, right? But with only one, this actually presents interesting possibilities of having this idea of having a component that implements a trait for a callback. And I'm going to get to kind of some of that cool stuff later. OK, so getting to the kind of the demos here. So I have these dependent components, which I defined in those other worlds. I use Jco for web and node. Obviously, we just saw Jco. Jco's awesome. I did Rust for a CLI. I didn't get to Go. I wish I had, because it's come a long way. OK, so really pretty basic. I found Jco to be super straightforward. It's much better in a lot of ways than Neon or other node binding tools because it generates types directly from WIT. So this is, with those other tools, I have to create, if I'm doing TypeScript, I have to create types files by hand for many, many structs. It's a real pain in the butt. But this, I can generate this directly. And then, of course, tsconfig. I mean, it's funny, bundling and tsconfig and rollup, all these things that I used for years without ever thinking about them are actually very hard if you're just starting for nothing, for me at least. So we generate the types, we build the component, we whack it all together, and then we serve it. Really, very straightforward, and it's all it's in the package.json if you want to pull this down. Jco for web. These are the steps, of course, leaving out the TS compilation and the bundle. Unlike other parts of the project, with the web, I'm not directly using a world. I'm not implementing a world. I'm just taking a component and I'm saying transpile this so I can use it in a web page. Obviously, this has the same TS challenges. The actual work took no time. The TypeScript took a long time. And a couple of challenges just around JCO, kind of things that still need to be done. There's no way to get a WASI stream from a JavaScript readable stream, at least not yet. So just in this example, I have to read the whole stream into a list U8 and then pass that to my SDK, to the main component. And so I basically have to take a stream, put it into a list, and then convert it back into a stream. Also, this is kind of funny because it's very unexpected. If you have to whack together a bunch of components in order to fully implement the world that you're then transpiling, the component you're then transpiling, if you don't do that, you get a CORS error, which is pretty funny. I just put that in there. That's just funny. So it's like it's thinking that this reference to this other world, this import, is actually a script, and it's going to give you a CORS error. I thought that was fun. OK, so let's demo. I've been encouraged by the other demos at the conference. So let's see. So I don't usually do live demos. And let me see if I can do this. Get to the terminal. I hope this doesn't take the whole time. OK. All right, so first, the web. I should have done Control-L, learned that from the Fermyon demo yesterday. npm run start. So it's going to do all those things I just mentioned. It's going to transpile it. It's going to serve it. And I'm going to go back to the web page. And I'm going to drop a file into it. See if I can drag in. OK, so here, this is here's this. Oh, it doesn't open it. It opens it on the wrong page. OK, so here's a picture. OK, it has a C2PA manifest in it. That's the important part. And so I'm going to give it a bunch of JSON. I'm basically going to read out that manifest here on this page. OK, it's a bunch of JSON. Yes, it's not very pretty for a demo, but it's actually what real APIs and SDKs do. They usually spit out a bunch of JSON. So I'm not going to apologize. And then, and as you can see, if I do the same thing with, if I want to stand up that node server, all right, and I want to curl that same file, I'm going to get the same result. So it's both node and web. Much less cool after Till's debugging of using the same component in JCO for web, but you get the idea. And then I can apply my CLI. Now this is actually a little more advanced. This is actually doing that signing. It's going to apply a new manifest to the file, and it's going to sign it with using Rust crypto in native Rust cryptography. And then if I want to take that new file, we're going to see that it's got a new manifest. So there it is. OK. So yeah, so that is the demo. Thank you. Right. Yeah, and that's the idea, right? It's a very complicated, the C2PA ARS SDK is very complicated. It's lots of cryptography. It's much harder. I'm still only learning the basics of it, but I don't have to. I can make components from it. So where do we go from here? Like, what am I going to abuse this time to complain about? So number one on my wish list, right over here. Yep, Java. So every time at Adobe I bring up Wasi, people are like, oh, so I can take my Java and compile it to Wasi? And I'm like, oh, no, you can't do that. So someday that story's going to change, and those guys over there are going to do it. The others are in kind of no particular order. Testing components frame, we've got this WIT. It should be easy to make testing tools. Now we've got the debugging. Let's get the testing kind of going. There is W-A-D-G-E, WAG for Go, but kind of a general purpose. I've got a component. I should be able to throw data at it. And for Rust, nothing I haven't already mentioned. And hopefully now with the async and then the threads, this stuff's going to just work. Tokyo. It'd be nice to not have to use nightly to compile my SDK to wasi-v2. Callback functions, it's going to happen. And then component support in browsers. I don't know. Sometimes we usually get some Chrome people here. I don't think we have any this year, but component support in browsers. And more on that in a second here. So more ugly slides, incredibly ugly slides. This is what I did. I made 3 components. I whacked them together. And this application part can be anything that can be, supports the component model, any language. The signer part can be anything that supports the component model. And I can put those together with my SDK's component and compose lots of different types of applications with different trust boundaries and cryptographical use cases. Users could compile their own signers, right? With wasmCloud, I don't have to whack them together. I can if it's performant, right? But these components can all be distinct. And multiple applications can all be paired with this single C2PA API component. Customers could specify their own configuration if we allowed, provided an interface for that. Components could be dispersed through a network of CDNs, cloud providers, traditional data centers. Which gets me to this next point. Wouldn't it be? And it's really ugly. Sorry. The browser, or something like the browser, so supports component model and supports some sort of WRPC connection, maybe over QUIC. The signer and the application exist where the asset is. So I'm editing a photo in Photoshop. That's where or a video. That's where it lives, and that's where the processing happens. I send up the manifest to an Adobe service that has the Adobe key that we do not want running on your browser. It signs that, yes, you used Photoshop to do this, and then comes back through the signer, through a WIT interface, to the user's key, and something that implements the signer function, signs it with the user's key on the user's device, and that's the actual complete workflow. That's a single API call going through WRPC. No REST calls, no JSON, just WIT bindings over WRPC. So I kind of see this as a future for kind of network use of applications. If we could redesign from scratch, knowing that most stuff that happens over the web is not text, I think web apps would look a lot more like this. Just programs running on computers, talking to each other. OK, so thanks. Thank you for allowing me to speak here. Thank you for listening. This code is all open source. And I am going to push my component someday to a public repo. Thanks.
Hi, Colin. Great talk.
Thanks.
A lot of complexity in the story. Could we maybe just align quickly on the why components? Because it seems like this was a really hard journey for you to climb. What had you so inspired to choose WebAssembly for this as your goal?
OK. Well, I mean, I've always been in WebAssembly. Well, I've been in WebAssembly for a long time, for different reasons. But this is the main thing, right? Is that it's a lot of work to do this. It's a lot of engineers, and it's a lot of language knowledge, right? You have to have a lot, and somebody who knows JavaScript, you have to have somebody that knows C or Python, or embedded, right? We don't, that's a lot of work. We can save a lot of work by doing this. We can also make services that are more flexible and easier to maintain. So that's the CAI story. If you want to hear the story about other stuff for why I got involved in WebAssembly, that's KubeCon next week.
So, okay, so what I, playback, what I think I just heard is doing all this cryptography to create these fingerprints for artifacts. You know, I take a picture, who took it, who edited it, who AI'd it, who put it on Twitter, who put it on TikTok, et cetera. Like this forensic record all the way down is very complex. And so by packaging it in Wasm, you can enable your whole ecosystem now to use the same engine everywhere. Is that right?
Yeah, right. Well, right. There'll be different components that interact on either side, but yeah, that's the big idea is one component can be used in multiple places.
All right, thank you.
All right. Thanks.